In this lesson, we're going to talk about BIOS and CMOS, two terms you've probably heard if you've worked much with PCs. To understand the BIOS and the CMOS and the role that they play in a PC system, you need to understand the fact that the CPU inside the PC actually doesn't know how to directly communicate with the other devices that are installed on the motherboard. It doesn't know how to contact RAM. It doesn't know how to contact the storage devices you've got connected to the motherboard. In order for the CPU to do this, it needs software. It needs programming. It needs a set of instructions that tell it how to communicate with these devices. Now, the problem is that the CPU can't store this software in RAM or on disk. Okay? Remember, we said that the CPU doesn't know how to communicate with the RAM natively. It doesn't know how to communicate with the hard disk natively. It doesn't know how to communicate with the floppy disk natively. So it can't load the software it needs to communicate with these devices from these devices. So how do we do this? Well, what we do is that we implement a special chip on the motherboard called a ROM chip. Now, ROM stands for read-only memory. Now, a ROM chip is kind of like a RAM chip, a random access memory chip. However, a ROM chip retains its contents even if the system is powered off. Unlike a RAM chip that we associate with typical PC storage that loses its contents when the PC is turned off. However, ROM chips, unlike RAM chips, can't be written to. Okay, whatever was written on that ROM chip when it left the factory is what's there. You can't add information to it. These ROM chips that we install on the motherboard contain hundreds of little programs that were burned into that ROM before it left the factory that allow the CPU to communicate with the various devices attached to the motherboard. These include the keyboard, disk drives, the memory, etc. Now, the hundreds of little programs stored on the ROM chip are collectively referred to as the Basic Input-Output Services, or BIOS chip. Now, we say the BIOS chip, but the problem is that it's not really the chip itself. It's not the ROM chip that's the BIOS. It's the software inside that's really the BIOS. However, be aware that in industry usage, we just call it the BIOS chip. Sometimes you'll actually hear the BIOS referred to as firmware because it's kind of a cross between software and hardware. Now, most of the ROM chips that we use in a PC system for the BIOS are about 64K in size. The CPU can read information from the ROM chip the same way it reads information from RAM. Now, devices that are connected to or part of the motherboard can be categorized into three different categories. We have devices that have no configurable parameters and aren't likely to ever be replaced. We have devices that have configurable parameters or that are likely to be changed from time to time. And then we have custom devices that may or not be present in any given system. Let's first talk about the first category of devices that have no configurable parameters. These types of devices can be handled by the BIOS alone. These parameters don't change, so nothing has to be changed in the programming that allows the CPU to communicate with that given device. These are devices such as the keyboard, such as the system speaker, not your audio speakers that you listen to music through, the speaker that's built into the PC case that just goes beep. These types of devices have no configurable parameters. You don't have to set anything in the BIOS to support these devices. The BIOS can handle them in and of itself. Now, the second category are devices that may have configurable parameters or may be upgraded or changed from time to time. Now, this set of parameters can't actually be handled by the BIOS alone because the presence of the device or the quantities or parameters may change from system to system. For example, memory. We may have 1 gigabyte of memory in one machine. We might have 512 megabytes in another machine. Same thing with disk drives. We may have a floppy drive attached. We may not have a floppy drive attached. We may have a hard drive installed in the system, but it might be a 40 gig drive. It might be a 10 gig drive. It might be a 250 gig drive. If we had just the BIOS alone, theoretically then, if you changed anything in the system, such as adding more memory or adding a bigger hard drive, you'd actually have to have a new BIOS chip that supported the parameters associated with these new devices. Because remember, the BIOS isn't rewritable. You can't change anything in it. Okay? That would be really unfeasible. Instead, PCs use a second RAM chip in conjunction with the ROM chip that can be written to and read from. This is called the complementary metal oxide semiconductor, which you never hear anybody say. What it's actually referred to as is the CMOS. Now, this is an important distinction to make because a lot of folks get these two components mixed up. They work together, but they do different things. The BIOS contains the programs that the CPU needs to communicate with the various devices on the motherboard. The BIOS is hardwired. It cannot be rewritten. It's ROM memory, read-only memory. The CMOS, on the other hand, is RAM, random access memory. Now, the CMOS contains the parameters these programs need in order to access certain devices. For example, let's say that we add a new hard drive into the system. Well, this hard drive has different parameters than the one that was in there before. We update the CMOS, the random access memory chip, with the new parameters for the new hard drive. Then when the CPU needs to access the hard drive, it goes and loads the appropriate programs from the BIOS, and these programs then check the CMOS to say, okay, I need to store data at this particular location on the hard drive. How do I get to it? The CMOS has the parameters that it needs. Whenever you add a new component, you can change the values that are stored in the CMOS. Now, together, these two components are sometimes called just the CMOS or just the BIOS. But whenever you hear that, kind of assume in your head that they're talking about these two different discrete parts. Okay? If someone says, well, I need to get into the BIOS to change this hard drive parameter, you can kind of puff up your chest with pride and say, actually, you can't access the BIOS directly to change anything. You're actually changing it in the CMOS. You'll be proud and they'll look at you funny. Now, the CMOS also is where your system clock is run from. You ever look down the bottom right corner of your screen and seen what time it was in your operating system? That's where it pulls its time from the CMOS. Now, CMOS chips are usually 64K in size. And just like any other random access memory chip, the data in the CMOS is not persistent. Remember that with the BIOS, the read-only chip, we're talking about persistent data. If you shut the system off and turn it back on, the contents of the BIOS are intact. CMOS, on the other hand, will lose its contents if it loses power. Well, that won't work, right? Because we don't want to have to reset up our hard drive parameters and our integrated components and everything every time we start the system, right? We want it to set it once and for it to just work. In order to do this, the CMOS has to have a constant supply of electrical current to keep its data intact. To do that, we have to use a battery. Because if we shut that system off, it loses power. We don't want to lose our contents of our CMOS when that happens. So we have a battery. It might be within the CMOS chip itself, or it might be external to the CMOS, depending on the motherboard. Either way, it uses a small battery. On older systems, it was 5 volts. On newer systems, it's 3.3 volts. Either way, this battery keeps the contents of the CMOS chip intact while the system's shut down. Now, there's 3 different battery options. In the old days, you could actually hook up an external battery to your motherboard, then it would be used to keep your CMOS contents updated. Haven't seen one of those in about 10 years. They're pretty much obsolete. Most systems use some kind of onboard battery. If you look on a motherboard, you can probably find something that looks like a big watch battery. That's what's used to keep your CMOS contents up to date. Now, even really modern, newer systems, they actually build the battery itself into the CMOS. So you won't find a separate battery. It's actually inside the CMOS itself. This brings us to the third category of devices that may or may not be present in any given PC system. These include devices such as soundboards, network adapters, etc. There's an endless variety of different types of boards that can be inserted in the expansion slots of a given PC. And within each category, such as soundboards, there's an endless variety of different models that can be installed. You could buy a soundboard from this manufacturer, that manufacturer. They all do the same thing, but they're built slightly differently. Your PC system uses one of 2 strategies to allow the CPU to communicate with these types of devices. The problem with this category of devices is the fact that there's just really no feasible way to build a BIOS ROM chip or a CMOS RAM chip that's extensive enough to accommodate every last different type of device that you could possibly put in the PC. So the first strategy is actually to put a BIOS chip on the device itself. Now this is done with devices such as SCSI boards that allow you to connect SCSI devices to the PC. These types of devices have their own ROM chip, and it's called an option ROM. To understand how this works, remember that we said that most BIOS chips are only 64K in size. However, do you remember how much address space is reserved for the BIOS? It's 384K. The space not used by the BIOS can be used to address these built-in BIOS chips on the cards themselves. Video boards also use this strategy. You ever turned on a PC and seen a little video message right at the very beginning as the system started booting up? That's because that video board loaded its BIOS into this address space so the CPU could address it through the address bus. Now, a second strategy is to use device drivers. This is the more common strategy that's used. That's for soundboards, network adapters, all kinds of other devices. In this case, we are not really using the BIOS anymore to address these devices. Instead, we use a device driver, which is a piece of software that's loaded by the operating system itself that tells the CPU how to address the soundboard or how to address the network board. A device driver is not persistent. With devices whose access is controlled by the BIOS itself, because the BIOS is persistent and the CMOS is persistent, we don't have any problem. Same with these custom devices that use a built-in BIOS chip. They load whenever the system's turned on. Again, we have a degree of persistence. Device drivers are non-persistent. If the system's shut down, the access for the CPU is turned off as well. When the system's turned back on, we have to reload the driver every single time that the system started. By way of summary, we talked about the fact that the CPU itself can't directly access other devices that are installed on the motherboard. To do that, we have to have software. That software is stored in the basic input-output system, or BIOS, of the motherboard. These programs allow the chip to communicate with these other devices. For some devices, we have to use the CMOS chip to store various parameters that the software in the BIOS needs for the CPU to access them. We also talked about the fact that there's a third category of devices that need device drivers, or else they need their own BIOS loaded into the system in order for the CPU to use them.